You're going to make it echo. All right. So I'm going to present my screen and get our warm up on the board. Alrighty, so you have 5 problems. I'm going to give you guys about 10 minutes until 10:10. So number 1, what is the perimeter? To find the perimeter, you need to add up all of the sides of your shape. So find the perimeter of the rectangle. Number 2, what is the opposite of negative 145? Number 3, when a baby giraffe is born, it is 5 feet tall. It will grow 1 25/100 feet each week. How tall will the giraffe be when it is 7 weeks old? So you might have to do a couple steps on that one. Number 4, you're dividing fractions. 3/4 divided by 3/5. And number 5, what is the remainder when 5,921 is divided by 15? So I'm going to give you guys about 10 minutes on this. Go ahead and be working, please. You guys will have markers out and be working on those, please. Does it still work? Then throw it away and get a new one.
You should ask somebody if they want their markers back. I thought like
Well, you should point out how you got it. But I would also like it to get.
Can I go from my water bottle? I mean, I didn't take them. I don't even know how
I don't know, just use this. Because we're gonna warm up things.
Yeah.
And there's only less. First it starts out at 7.
Add up all the sides. Add all the sides up. About 5 more minutes.
How did you wrap it up like that and get this one?
You need to multiply and add. Okay, about 2 more minutes. 2 minutes.
Where did you get 87? Yes, 75. So,
I have a super line.
oh. So now when I live and I said I did add on number 3, you can multiply. Figure out how tall it is.
Super line.
Right. Put your glasses back on.
Oh, you know.
About 1 more minute.
He's so far away.
Well, I didn't know the first one. I don't think I added.
Okay, no, now I lied again. You do have to add. I'm sorry. We'll do that problem.
The first one?
Yeah.
So did I get it right?
No, not the first one. The third one. Okay, let's start going over these. So let me make sure that we can see the screen. Good. Alrighty. Can we see everything behind me? Are we good? Okay. So to find the perimeter of a rectangle, it's like you're finding the amount of fencing that needs to go around the outside. You need to add together all sides of your rectangle. But it only gives us 2 sides. What do we know about the opposite ones? If this bottom one is 30 and 25 hundredths, the top one is the same length.
And the side,
And the side is going to be what?
12.4.
12 and 4/10. So we need to add all these numbers together. So we have 30, 25 hundredths, 30 and 25 hundredths. Let's just start with this. What is 5 plus 5? 10. Carry 1. 1 plus 2 plus 2. 5. What do I do with this decimal? Bring it down. Remember, you always line up your decimals, so it drops straight down. What's 0 plus 0? 0. And 3 plus 3? 6. So we've added together these two sides. Now we need to do the other two. I'm just going to keep adding it to it. So we're going to line up our decimals, 12 and 4/10. What do I need to add right here? Got your placeholder 0. What's 0 plus 0? 0. What's 4 plus 5? 9. Drop down your decimal. 0 plus 2? 2. And 1 plus 6? 7. So that's one side. And we have one other side to add together. Make sure you line up your decimal. 12 and 4/10. Add your placeholder 0. And we can add. What is 0 plus 0? 9 plus 4? 13. Carry your 1. 1 plus 2 plus 2? 5. Don't forget that 1 we carried. Make sure your decimal is there. And 1 plus 7? 8. So the total perimeter of this thing, whatever this rectangle is 85 and 30/100 or 3/10 if you want to get rid of the 0 inches.
Oh, yeah. Well, no, I thought you must have.
Okay. Number 2. What is the opposite of negative 145? Good. The negatives just cancel each other out and become positives. And you have positive 145 is your answer. Yes, Miss Dolphin?
Oh, I got it right. What's the opposite of negative?
Positive. Oh, you're right. Oh.
No, I got it wrong.
It's just going to be negative. So this number, if you look at it, becomes a positive 145, correct? Then we need to take the opposite of 145.
Oh, I got it right.
So it is a negative 145.
Yeah, what's the opposite?
So yeah, it says take the opposite.
So negative 145 is positive, but then you have to go one step further and identify the opposite of what that means.
Yeah. Yes, right.
I remember doing this before with an equation like this, and I did negative something, and then you said it was positive, and then I was asking for the opposite of that.
I might have read it wrong. Sometimes it happens. I'm not perfect. I never claimed to be. I know. All right. Next one, we have a giraffe that is born 5 feet tall. Each week it grows 1 and 2,500 feet. And we need to figure out how tall it is at 7 weeks. So first we need to do some multiplication. We need to take 1 and 2,500 feet times the amount of weeks that it's going to grow. 1 and 2,500 times 7. Okay? What is 7 times 5? 35. 33. What is 7 times 2? Plus 3? 17. Carry 1. And 1 times 7. Well, 1 times 7 is 7. Plus 1 is 8. What do I do with my decimal? If there's 2 behind the decimal, move it twice this way. Good. So you have 8 and 7,500, but that's just how much it grows in 7 weeks. How tall did it start off as? 5 feet. So we still need to add the 5 feet to it. So we can line up our decimals, and we get 30. Yeah, good. It's 13 and 7,500 feet tall at 7 weeks old. That is really tall for 7 weeks old, right? For a giraffe.
Oh, giraffe.
You know giraffes have a fight in this.
Yeah, when they fight, they like whip each other with their heads. It's an interesting. Yeah. All right. Number 4, we have 3/4 divided by 3/5. We need to do what to this? Good, KCF. Keep, change, flip. Keep, change, flip. Keep 3/4. What do I change my division to? Good. And what do I flip 3/5 to? 5/3. Good. Now we can do our classic multiplication just straight across. What is 3 times 5? 15 over 4 times 3? 12. Good. Well, you can either divide first to simplify, or you can simplify first. Let's do a little bit of, it will be the same answer. Let's simplify a little bit first. What goes into both 15 and 12? 3 goes into both. 3 and 3 What is 15 divided by 3? 5. And 12 divided by 3? 4. So now we have 5/4. We still have an improper fraction. What do I do to change this to a mixed number? Divide. Always take the top number and divide it by the bottom. Does 4 go into 5? One time. Subtract and you get 1 again. So remember, this big one that it goes in fully is your whole number. Your remainder that's left over is your numerator. And what you divide it by is your denominator. So you get 1 and 1/4. Yep. 125%. All right, and then we have one last one to do, number 5, some division. I don't remember the numbers though, so let me go look. 5,921 divided by 15. Alrighty, so let's do this division and then we will look at some practice problems for the day. We need to figure out the remainder for this problem. Does 15 go into 5? No. Does it go into 59?
Yes.
How many times? 3 times. What is 3 times 15?
45.
45 goes below. Good. What do you subtract and get?
14.
14. Ooh. Good. Drop down the 2. So we have 142. Does 15 go into 142?
Yes.
How many times?
9.
Okay, so someone said 8 and someone said 9. Let's do 120, 15 times 9, 135. So it's going to be 9. Goes in 9 times. 135. You have 7. Drop down your 1. 71. Does 5, not 5, 15 go into 71. How many times?
4.
4 times. This one's 4. Because it's 60, right?
Yeah.
Subtract and you get 11. So our answer is 394?
No.
No, why not?
I said the remainder.
Good. It wanted to know what the remainder is.
I did 5.
So you get 11. You divided it by 5 on accident?
Yeah, I did.
That's all right. So our remainder here is 11. That's kind of a long one, but that's all right. Let's go ahead and look at some notes. So we should have something posted on Google Classroom for today. Let me go ahead and get that pulled up. How are we doing online? Doing good? Yes, no, maybe?
Yep.
Making sure you guys are still there. All right. Quickly. All right, so on Google Classroom, I'm pretty sure it posted, right? Under math, you should have, yep, algebraic expressions, whole group practice. We're going to do some all together. There's a couple on here that you'll do on your own to practice, but we're just going to kind of practice what we learned yesterday with algebraic expressions. So let's go ahead and open that up. Everybody should have their own copy. We will turn it in when we're done because you guys can still see it after. I just want you guys, I want to make sure you guys are following along as we do this. So you will turn it in when you're done. Keep that in mind. So I'm going to give you about a minute to get this open, and then we will get going. Algebra is difficult. It's one of the harder things that we do. Are we thinking the same thing?
What was the question?
Dallin asked, what do I think the hardest thing that we learned this year is? In math. We'll stick with math.
Oh, we're totally thinking the same thing.
All right. What do you think? Yeah, I was thinking a specific part of
Yeah.
Yeah.
So that part makes me happy.
Yeah.
I was thinking, I've always heard that, like, the some people are really good at algebra, and some people are really good at geometry, like the shapes and all that stuff.
Mm-hmm.
But it's really hard to find like people who are really good at both.
Unless you're me.
Geometry and shapes and stuff is more visual, and algebra is more logic.
Yeah,
I was definitely an algebra person.
I was a both person.
Wow. Right?
Project.
Alrighty, so maybe reload the whole Google Classroom. Then. Close it and reload. All right, so let's go ahead and get looking at this. So there's a little bit of notes at the beginning just to review as well as practice with, have it all there for you so it's on the same document that we're going to practice with. So if you forget what something is, like let's say we're on page 2 and you're like, oh man, what's a coefficient? Where can you go look? People. Or on the first page where it has definitions. There's a reason I put them all there. So let's review these. First of all, an algebraic expression is something that does not have an equal sign, right? It's just numbers and letters with adding and subtracting, sometimes multiplying and dividing. So it's a combination of numbers, variables, and at least one operation, and you can't solve it. You can simplify and make it into smaller numbers, but you cannot solve it because there's no equal sign. So an example is going to be something like 3y minus 5. Another example is up here at the top, 7x plus 12. There's numbers, there's a variable, and there's an operation. In this case, it's addition. In this one, you have numbers, a variable, and subtraction. So it's just basically what we've been doing before without equal signs. And now we get to see variables. The next definition we have is a term. Should I zoom in on this? There you go. Terms are a number, a variable, or a combination of a number and a variable, and it's always separated by an addition or a subtraction sign, sometimes multiplication and division. But something like 8 is a term because you're going to add or subtract it. A letter, also known as a variable, all by itself is a term. And then if you combine them, 5 times x as a variable, not a multiplication sign, but as a variable, that's a term as well. Remember when you see 5 and x smushed together, they're married, what sort of operation is happening between them? Good, they're being multiplied. Keep that in mind. So if we look at this example right here, 3y minus 5, there are 2 terms. One of the terms is 3y, variable and a number smushed together, 3y. And then the other term that's on there is 5, because it's just a number. Chill in there. All right. Our next definition is variable. It's a letter that represents an unknown. It's the letter that you see in your expression. So if you see a Z, it's a variable. If you see a B, an A, any letter. They don't usually use O. I don't think I see it.
Like 0.
O looks like 0, so O is not used very often. Yeah.
Why do they call it a variable?
Because it can vary. I had to think about that one for a second. It's a good question. Yeah. Miss Daphne asked me why it's called a variable. She confused me for just a second. I thought she was trying to trick me, but then I was like, no, she's not. A variable is called a variable because you can put any number in there. Your number can vary from anything. It can change. It's able to vary. Remember the able part that we learned yesterday in ELA? It's able to vary. Yeah. Yeah. Our next one is the coefficient. This is the number that is being multiplied with a variable. So 3 times n, it's the ones that are married. They're being multiplied. The number 3 in front of the variable is your coefficient. Yep.
So, every year when we look at algebra and coefficients and variables, I see you guys get a little bit confused when you see a number directly next to the variable, because oftentimes sometimes you like know to plug in the number, let's say in 3n, the n is 6, but sometimes you guys just write like 36 because you're substituting it, but you forget to perform the actual operation. So that's one thing I see a lot of, is they just like rewrite it.
Mm-hmm. So in between the 3 and the n, this is why I keep telling you that they're married and they're being multiplied. When we start tomorrow, we're going to start replacing variables with numbers so that we can solve it and get numbers like actual. We're going to do substitution. So once we start doing that, instead of this number, this letter n being just a number and you get 36 or 34, you got to remember that there is multiplication in between here, 3 times whatever the number is that I give you. Yeah, it's like an invisible multiplication. It's there, you can't see it. You just have to remember that there is invisible multiplication in between the number and the letter. Okay. Our last definition here is the constant. It's the number that's being added or subtracted. In this case, it's a 25. This one has no variable attached ever. It's just a constant number that's always being added or subtracted. That's why it's called a constant. It never changes. It's always added or subtracted from your expression. So let's do a little bit of practice right here. Underneath it said, let's name each part of our expression from 7x plus 12. Yes, Charlie.
I will get some.
We're about to do them right now. Okay. So the terms are the numbers and letters, or a combination of a number and letter. They're always separated by an addition or subtraction. So in this case, there are 2 terms. It's just the 2 things that are being added together. What would be our first term here? Out of 7x plus 12. 7x, it's the whole thing because it's one thing combined. 7x is our first term, all together. Okay? And then on the other side of our addition sign, what's our other term here? 12. The other one is 12. So it's separated by the operation, addition or subtraction, and it's just whatever's on the other side. 7x and 12. Okay. And then on these ones, you should be typing along with me, following along. Our next one is a variable. What is the letter that you see in this expression? X. That's it. Our variable is x. Okay. The coefficient, that's the number being multiplied by our variable. What number is being multiplied by the variable? 7. It's the one in front of our variable. 7. And finally, our constant, the number that's always added or subtracted in our expression. 12. And those are the parts of our equation. We're going to do quite a bit of practice on the next page with this, so we will keep practicing. Alrighty. I'm going to go ahead and scroll down. Underneath, we have some practice ones if you want to highlight the actual things. I didn't separate them very well because I didn't have enough room. So there's a couple things that we're going to talk about on these ones. I'm just highlighting the expressions so that they're easier to find and they're not in the way. So these are the ones we're going to do together. Our first one is 9s minus 3. Let's start with the variable. The easiest one to identify. What's the letter in our expression? S. It's the part, it's the letter. Yeah. Okay. Then I like to look for the coefficient after that because it's always attached to my variable. What letter is being multiplied, or sorry, not what letter. What number is being multiplied by my variable? 9. That's the constant. And then the constant is the thing being added or subtracted. Now this is the part that gets a little tricky. What number is it? 3. But since it is being subtracted now instead of added, it's a -3 because you're subtracting it. You're always going to be doing a -3 on your problem. Does that make sense? You're going to take the subtraction in front, and it's a -3. We're going to solve it tomorrow. Tomorrow I'm going to tell you that s equals 2, and you're going to have to take out the s and plug in a 2 for that. So it would be 9 times 2 minus 3. The numbers mean a number, and you don't know what the number is until someone tells you, or the problem tells you s equals 4, and you can plug in the number 4 to simplify it down. Yeah. This is where order of operations and PEMDAS is going to come into play again after this, because we'll have multiplication first and then you subtract type of thing. So we use all of our stuff all the time. Let's look at our next one. Y plus 12. What's our variable? What is the letter? Y. Good. All right, now let's see if you guys can get this. What's the coefficient on this? There is not nothing there. Not 0. It's 1. It is 1 because there is one y. If we were to just put a 1 in front of this, it would be 1y. But this is one of those cases of invisible math again, where you don't have to see the 1 for it to be a 1. So there is one y there. So the coefficient is 1. It's an invisible 1, essentially. And then we need to tell or type in our constant. What is the number being added or subtracted? 12. And it's a plus 12, so it just stays positive on this one. Okay. Not all of them are negative. If you're subtracting the constant, it's a negative. If you're adding the constant, it's positive.
So if there's an add or subtract sign, it's a negative number?
If there's a subtraction sign, it's a negative. If there's a positive sign, it's a positive. Or an addition, it's a positive. Okay. All right, let's look at our next one. 15x. There's just one term here, 15x. There's no adding or subtracting a constant. So let's start with our variable. What's our variable here? X. All right. X is our variable. What's our coefficient? What is being multiplied by our variable? The number 15. Perfect. Now for the constant, do we see anything being added or subtracted? It's not 1 this time. It's 0 this time.
0.
Because there is nothing there at all, right? This one is a 0. Lots of little things to remember, huh? There's an invisible 1 in front of just a variable. If there's nothing added, it's 0.
Why would it be a 0?
Because you're not adding or subtracting anything. So if you were to add a 0, if it was y plus 12, that would be 1y plus 12. If you have 15x, and let's say, so right now there's no constant, right? It's a 0. Because that's because if we were to do a plus 0 and add our constant, it doesn't change it at all, does it? By adding 0. So without that 0 there, it's the same as just saying 15x. Because you can add or subtract 0 to anything, it's going to stay the same, right?
Oh, yeah, it can be negative or positive.
Right, because 0 is not negative and it's not positive either. So it's just right in the middle. So yeah, so adding or subtracting 0, that's what your constant is. It just stays the same. Yeah. All right. Our next one, we have x minus 9. What is our variable? X. Good. X is our variable. What's our coefficient? 1. Good. You have an invisible 1 here. Good. And the constant is a -9 because you are subtracting 9. Perfect. Is this making more sense the longer we do it? Good. You guys are gonna do a couple on your own next. So
I need to go.
Very confused.
bless you, I think. Someone online? I don't know.
Myself.
This one, I think.
All right, and our last one.
Does she just say?
We just have z. Z is all by itself. What is our variable? The z. Good. The coefficient is 1. It's like having an invisible 1 there. There is one z. What's our constant? 0, because you can add or subtract 0 and it's not going to change the value of your expression. Yeah. Mhm. Okay. Yep. So now below that, I'm going to scroll down just a little bit. You have some independent practice. I'm going to give you guys, let's say, 5 minutes. How many problems are there? There's 4. So we'll do 5 minutes. I'm just going to highlight them so that you know what they are. It is possible to have 2 variables, 2 coefficients, 2 constants. That is possible. So if you need to list multiple things, you can. Does that make sense? Okay. All righty, go ahead and work on that. Yep, it can be flipped. Try these out and then we will review them, but I would like you to try them on your own, please. Let's take about 4 minutes now.
We'll do about 1 more minute.
Alrighty, we're gonna go ahead and go over these because we don't have a ton of time left. So, our first one, 9n. This is one we have done before. Very similar. What's my variable? N. What's my coefficient? 9. Good. The number being multiplied by the n. What's my constant? 0. We're adding and subtracting nothing, so we can put 0. The next one's a little bit harder. We have 2 variables and 2 coefficients. So, what are my 2 variables? N and x are my variables. What are the numbers being multiplied by them? My coefficients. 15 is multiplied by the n, and 5 is being multiplied. Well, actually, it's not just 5. What's in front of the 5? It's a negative 5 in this case. Whoa, that really spaced out. Whatever. You guys can still tell, right? Okay, is there a number being added or subtracted? That's all alone, no variables attached. Do we have a constant here? No, so what will it be? 0. What's up, Mrs. Mills?
Are you actually having them solve the word problems or just write them as equations?
I'm just having them write them as expressions and stuff today.
That's what I was thinking, because I didn't really want to go into that whole thing.
Does it have them solve it on there?
Yeah, well, it gives you enough information that you could solve it. It doesn't really.
Oh, no, I'm just gonna have them write it today and we'll solve tomorrow. Yeah,
Because are we solving this week or something?
we solved this week, starting tomorrow. Okay, cool. Sorry, Mrs. Mills came in. She's nice. Okay, here we go. 23 plus 2y. What is my variable for this? Y. What is the number being multiplied by y?
2.
Good. 2 is our coefficient. And what is the constant being added or subtracted? 23. Now this last one, 36 minus n, is a little bit different. It's flipped, right? So that makes it a little different. But our variable is still the same. What's our variable? N. Now this is the hard part. What's the number in front of n? Yeah? The coefficient is 1. Good, but there is a subtraction sign in front of it, so our coefficient is -1 on this one. There's a subtraction in front of it, it's a -1. And then, are we adding or subtracting a number to it?
Yes.
What number?
36.
36 is our constant on this one.
So are we gonna have to
Yeah, we're gonna keep going. There's a little bit more. Good. So hopefully that was a little bit more helpful after yesterday. I think you guys are pretty confused after yesterday, but did it help clarify some stuff? Did we get more used to it? What about online? How does it feel a little bit easier? I'm taking that as a yes from the online.
I'm still kind of confused on it.
Yeah, this is a hard topic, so I think the more we do it, the easier it'll get. Okay? Good. All right, let's go ahead and look at the next page. We have a table to fill out. We're going to do this all together because we haven't done a whole lot of this yet. We're going to write the algebraic expressions from words now. So if we look at our first one, our first box right here. There we go. We need to fill it out with the expression that goes with the number sentence, 9 more than D. That's multiplying it though. If we're doing 9 more than D, you're going to start off with your variable, which in this case is the D. And then if I'm doing 9 more, am I adding, subtracting, multiplying, or dividing? We're going to add how many? 9. It doesn't matter with addition, but when we get to subtraction ones, it will matter. Yeah. Plus, I got plus from the more than. 9 more than. Not always. On the typing thing, I made it up. What are you talking about? The plus. Oh, that's, you didn't say plus. You said more than. The plus is up by the backspace. You do shift equals. It's up by the backspace. Shift equals. Yeah. Our next one is 9 plus 20. We need to write this similar to how the one above it is written. So we need to write this as words. And I don't want to just write 9 plus 20 because that's too easy. Let's make it a little bit more difficult. How else can we write that? 20 more than 9 works. 20 more than 9. Because we are doing 20 more than 9. 9 plus 20. Say that again?
Do all the teachers, like, does everyone in the whole school have the exact same time as the kid on the
No.
Really?
All the teachers made their own schedule for their days. Yep, this is just the one that works best for us. All right, let's look at our third one there. 3 less than P. What does less than tell us?
Subtraction.
Good, subtraction. So now the question is, am I going to do 3 minus P? Or am I going to do P minus 3?
P minus 3.
Good. P minus 3 because we're doing 3 less than P. Good job, guys. This is probably one of the harder things that we do. Writing these expressions is really difficult, so it's all right. Okay, Skylar, focus, please. Less distraction. All right, our next one, we have Z divided by 3. This one, division in general, is very difficult to write fancy. So honestly, on these ones, I typically just go with Z divided by 3. There's not a whole lot of other ways to write these ones. So Z divided by 3 is most usually how it goes.
I know another way to say it.
How?
Three times as much. If you divide
Kind of. Yeah.
divide, words that you go backwards and not divided,
Divid.
Divide by
It's true, but divid is not a word. Alrighty, and let's do our last one. This one says 6 times as much as K. What does the word times tell you?
Multiplication.
Good. Now we could do something like 6 times K, correct? With the multiplication symbol? 6 times as much as K. 6 times K. You guys are all on the right track. K times 6 works too. But we also now know how to write these without our multiplication symbol. You can just write 6K because we know that there's invisible multiplication there now that is just 6 times K. I know, this is a lot of information. Just not K6. Oops. So Elijah's asking me if we can do K6. It does mean the same thing technically, but in algebra, when we see numbers and variables pushed together like we do, you're always going to see the number before the variable, like the first one, 6K. So yes, technically K6 is correct, but when you see algebra, the farther you go into your math career of schooling, you're going to see it with the number first and the variable second, almost always. Okay? Ask first. Yeah, I wish we had $6,000. It'd be nice. All right. How much time do we have? I think we're okay with this. We might, if you guys would like to attempt to write these, go for it. I was going to do them together, but we're kind of running low on time. So I think what we're going to do instead is you guys can turn this in when you're done and you've got it all caught up. Those of you that are online, we have science at 12:30 like normal.